So I'm loud enough. Welcome, everyone. Thanks for coming out. I hope you all had a great conference so far. And welcome to my talk. And it's actually a good timing for my talk for the second day, almost end of the day, and everyone is tired. And that's about the right time that everyone crashes, right? So you're in the right place. We're all gonna crash today. But don't worry, you got me. Just sit back, relax, while I take you through this crash course. Yeah, you see what I did there? But before we go any further, let me show you who I am. So I'm Jafari. I am a software engineer at Revolut. Definitely reach me out on Twitter. I would be happy to say hello to every one of you. And if you want to check out my Rusty blog, just head down there. It's like as old as that icon. So yeah, ashamed of that. All right, so right down to business. What is a crash? So who knows better than our beloved friend Wikipedia? Like in computing, a crash occurs when a software application stops functioning properly and exits. I mean, that's good, but we can do better, right? So I have my own definition. That's when a program stops working unexpectedly. I hope that one is a lot better. So now we know what's a crash. Let's see how crashes actually happen. The first and the foremost reason is us, right? We are the developers, we create bugs, and the software crash. So the first one is software bugs created by us. And the next one is either us or them, right? Hardware developers. So hardware issues can be a reason. And you think I am done with the reason, but sorry to let you down, there is another one. Galactic rays. This one is super interesting. Definitely go check it out. It blew my mind, but out of the scope of this talk, so sorry. Today I'm going to focus on software bugs because here we are developers, right? Not hardware. And there are many more reasons for what a software bug could be caused of. The only one that I'm going to focus today is exceptions. And so, yeah, let's see what's exception. Exception, by definition of this time, not Wikipedia, gotcha maybe, Techopedia, pretty close, right? So an exception is an abnormal or unprecedented event that occurs after the execution of a software program or application. It's a runtime error of an undesired result or event affecting normal program flow. I don't think any one of you will remember that in 5 minutes. So I have my own version. My own version is anything that you didn't think of or it's not acceptable is an exception. Cool. So by that definition, exceptions are for exceptionals. Some of the examples, some of the theoretical examples are when something terribly goes wrong, I mean, that's an exception. The one that is not acceptable, again, that was in my definition. Hey. No way, I'm gonna let you pass. That's an exception. I'm not gonna let you pass. And the last one is does not meet the rules. So something doesn't meet the rule is just, I'm gonna go out. I'm gonna be an exception. So on theory, it looks good. Some of you might already know about it. But let's see a quick, simple example. So if you do this in a JVM land, Java is gonna go crazy and say, listen, buddy, this is not accepted by me, so you wanna do division on a 0, and I don't know how to do that. So take it to your own means. I'm not gonna do that for you. And you get as a result, you will get an arithmetic exception, hopefully. But in Kotlin, you'll get even better, something better called lint error, so you won't even be able to run it probably. So that's our exceptions. Now, we are all aware of exceptions, right? At least even the first day you start programming, the first thing you see before the first hello world is going to be an exception, either by the compiler or by the code you wrote. So I'm sure all of you have seen it, but let's remind ourselves with some of those friendly faces. So the first and the foremost, by far, I mean, null pointer exception. This guy is so far high up that people like to call him $1 billion mistake. A mistake. And the next one is IO exception. So the order here is just my own preference. Your order might be other way around, but it's still the same thing. So don't worry about the order. And if I'm missing something, just because I'm not facing them as often as the others. So no worries again. Just 1 second. All right. The next one on the list is out of memory error and Stack Overflow error. Oh yeah. So I cheated right away here. And the first two are actually exceptions, but the last two are not exceptions. They're error. The difference, there's a subtle difference, and that's the exceptions are thrown by us, developers, and the errors are thrown by the system. So you can see the out-of-memory error is usually, you don't do that yourself. The system will do it for you. That's a difference. But for the sake of this talk, I'm going to keep it simple and call all of them as exception. But if you want to follow the Java rules, they're all throwables. All right. So I call them, or especially the null pointer exception, MPE, and a billion-dollar mistake. And there is a very long blog post explaining that. But if there is mistake, and we learned our lesson from 20 years ago since Java was born, so we shouldn't be thinking of creating new ones, right? Right? No, we are actually creating new ones. Actually, our beloved language, Kotlin, just created a very friendly face called invalid mutability exception. And if you ever touched, by ever, literally even once, touched threading on Kotlin native, you will see this guy. This is so famous that they actually forced JetBrains they noticed it, and they decided to move away from the approach and create a new memory model altogether just to get away from this guy. One of the reasons, at least. So they're not as a mistake as we used to call them. We are still creating them. They're still in business, and we are creating new ones as we go down. All right. So here, I'm going to present you with one question, and one only. And that is exceptions. Are they good or bad? So this question is actually supposed to be at the end of the talk, but I'm going to leave it here, and I'm going to plant it in your brain on a different thread. So while I'm talking, listen to me on a different thread. Think about this question, right? And then I want you guys to leave this talk and think about this question whenever you're back at your desk and trying to write code for another second line for another 20 lines or 10. So yeah, right now I'm not going to answer it. No, not now. But at the end of the talk, we're going to have another look at this question. All right. Before we go and see a real use cases and example of exceptions and how to deal with them, I'm going to set something very crystal clear, and that's exception-driven programming against if-else. Let's see a round of hands who thinks exception-driven, who has actually tried it, and who thinks it's actually good. Come on, no one? You didn't try exception-driven programming ever? Oh, someone did. You weren't brave enough. Okay, cool. One person. Okay. In fact, it's not good. Don't try it. And there was a reason for that pause. The reason was exception-driven programming is not built for Java. And if you want to dig deeper, go check out Effective Java 3rd edition, chapter 10, item 69. And check that. It goes into much more finer details and explain why it is not a JVM thing and why it might actually decrease your performance, and you should avoid it as much as possible. So don't branch your code based on exceptions. Use if and else, return booleans, just try to use if and else. But that doesn't mean exception-driven programming is also completely bad. No way. There are languages that welcome it. So Elixir is one of them and says, throw me in exceptions and I know how to handle them. The language knows even better than the developers how to handle exceptions, so it's advised to not try catch them. So exception-driven programming is bad, but only on Java. On other languages, different story. Go check out Elixir if you're interested in that. Now, as I promised, use cases and how to deal with them. First of all, let's see a catching example, right? Because it's catchy. The network responses. So Usually, we have a network API that we try to fire a request to and get the response. And to abstractly wait for the rest of the app architecture, we wrap it around a repository. And let's call it an awesome repository. And why not? So if you don't catch the exceptions that are thrown by your network layer, and I hope everyone by this time that is running on JVM is using OKHTTP because, hey, we are in 2021, right? So if you're using OKHTTP for your network layer, OKHTTP does a good job of throwing million type of exceptions. And if you don't catch them in your repository and you let them pass and leak to the upper layers, then you're technically not doing a good job of implementing that repository. Because the sole purpose of repository implementation is to abstract away where the data is coming from. And if the callers know you got the data from network, then where is the repository? So definitely catch those exceptions that are fired from your network layer and wrap them inside a meaningful domain data layer, domain data object, and pass it backward. All right, another example. So I love this one. We have a lot of lights in every room, even this one, and we use this enum to present the light switch state. So light is either on, off, and unknown. Okay, fine. Let's see why that unknown exists. So we have a function that we map from string to our state object. The way that we do it is just we look through the enum states, and then we find the one that matches our string, and we try to return it. In case we don't find it, fine, we return unknown. But are we doing a good job here? Is this function doing its job? I mean, we have an state, and in real life, a light has only on and off. So what does an unknown mean here? It doesn't have any meaning. It doesn't provide any value. So it's either on or off. So let's remove that. That was the wrong one. We're removing it by making the function nullable, because if we don't find it, we have to do something about it, right? So it's either on or off or null. How come we are any different from the previous case? We are not. We are just we are symbolizing, we are showing the unknown case with a null value. That is still the same thing. All right, so how do we fix it? Simple. Just forget about the nullable case, convert the find to first, and return a non-null object. You guys might argue that this will crash. Yes, it will crash. That's what I'm here for. So I'm here to suggest that let this crash, because it's not the responsibility of this function to handle the edge case. This function's sole purpose is to just map, or as a factory function to create this state for you. It's not its job to handle the edge cases or handle the wrong argument that someone else decided to pass to it. No, it's just supposed to create that state object for us. And that's all. So take out the responsibility from this function and pass it to the person responsible for passing the wrong argument. Not this poor little guy. Sorry, dude. Moving on to the next one. So we have view binding and fragments. Oh boy, I love them. In fact, these two examples of my talk came along when I was creating this slide. So I was focusing so much, and then somebody messaged me on WhatsApp and said, do you know that view binding and fragments have problems with each other? I was like, how they have a problem? They are two different things. And he told me that, no, they crash. When you use a view binding and fragment, they crash. I was like, no way. And then we dug a little deeper, and I found out the crash was something totally unrelated. But he was blaming fragments and view binding. Let's see our example. So again, we have an awesome fragment because we are building an awesome app. So we usually create our view binding variable like this. We set it to nullable because it can be null at certain point of time. And then we create functions around our views, and we set the desired value to our views using the nullable view binding. You think it's doing a job, right? You think it's a good approach. But again, I would argue with you, because this function has only one purpose and one only, and it should just set the title. if you call this function at the wrong time, it will not set the title. And it's doing the second thing, which is not setting the title. What you want is to change the definitions a little bit, define a backend variable, and hopefully by next Kotlin version, this second variable will be gone, so you don't have to do it. And it will be taken care of by the Kotlin compiler. You set it in onView created and destroy it in onView destroyed. And then you just use the second variable as normally. Again, I see minds are blowing as this code would be. So you would argue that this would crash. Yes, it would crash. But again, it's not the problem of this function that the app will crash. It's the problem of who's calling it, because they're calling it at the wrong time, at the wrong place. So if you want to fix your crash, don't just come here, I know how to fix it. Just, no worries, I know how to fix it. Wrap a try catch here. Yes, we're good. We can go home now, Friday late afternoon, and we're fine. No, you're not. Let me tell you that. No, you're not. What you did was just moving the responsibility of someone else to your code just because they were lazy. Tell them you're calling this function in the wrong place at the wrong time, and you got to fix it, not me. I'm doing a good job. I'm setting the title for you. Fine. So this is the last example here, and this is a little bit controversy because everyone has a different type of business logic. But I try to bring it down to as much as possible and make it simple. So here we go. We have a function called pack3books, very precise. And then we accept a list of books, and then we return a book pack, which I assume is going to be a book pack of 3 books by the name of the function. And the first thing I do is to make sure that the size of the list that is passed to me is correct by requiring it, and then return the book pack as I create it. Again, here I will crash if you pass the wrong argument. If you pass me a list that is 1 book short or 1 book extra, what do you want me to do? I'm not Harry Potter. I'm not going to create a book for you. Do it yourself. I've seen friends, and by seeing, I mean a lot of friends. I've seen friends that go crazy. Look, your function is blowing up a lot, so I'm going to wrap it around the safe layer, and I'm going to create a safe layer function for you and create a try catch. And if you throw up, I'm going to blow up. I'm going to return a null. So that's how they fix it. But that is absolutely wrong, because instead of fixing the problem, which was passing the wrong argument, at least the number of arguments, they tried to silence the error, which was meaningful. They tried to just say, shh, I know what I'm doing. No, you're not. You're actually making it worse. Cool. And so far we saw example of catching and letting them pass. So we have both options to choose. Now I'm seeing your faces. You're going, but I know that but. I've heard it enough. So your argument is about exceptions versus UX. So if you see this pop up, and I've been seeing it quite a lot with Google Play. Thanks, Google. They're not here, right? If you see this pop up for application, what you will do is, if you're a good user, you will leave a bad review for them, and they will find it out and they'll come and fix it. And if you're a bad user and you don't want to tolerate it, you just go and uninstall it. But if you're a psychopath, you would actually flip your table. So depending on what type of a user you are, you will choose one of these 3. And so what I'm trying to prove here is, yes, seeing that pop-up is actually against the UX. So it will harm your UX. It will make your users go crazy. And it's not good. I almost got you, right? So let's quickly fix it. Try catch everything, safe layer everywhere, and add set thread on-call exception handlers to all of your threads that you're launching. And now we are safe. Are we? Are we really safe now? Are you happy with this? Let's see how happy you are after the next slide. So let's see your definition of safe UX in this slide. Again, very simple example. Let's imagine in our app, we have a simple button called Pay. And we enable that button for the user to allow to click on it on the right moment of time. What happens if we don't call this function at the right time? Users will just keep tapping on the button without anything happening. How long will it take you to fix that button, fix that problem essentially to enable the button at the right time? Forever. Like, have fun finding that issue, and the whole company will be crazy because this function is not doing its job. All right, how do we fix it again? Back to our previous slides. Just remove that nullable and let the function do its job. But again, we'll see that argument of crashing. Fine, it will crash. Yes, it will crash. But the whole company will be looking at that crash because the button is very damn important. So they will call you during the weekend. They will ask you to come to the office to fix that crash because we are not getting any revenue because the button is not enabled. And how long does it take you to fix it? Immediately, because lives are at the stakes, right? Are you convinced? I don't see that faces. You're still not convinced. So you still think that exceptions don't bring enough attention. Sure, you're taking that road, fine with me. How about this? But that was on purpose because now everyone is looking at me. And that's exactly what crashes do. People crash. Not people, but the apps. So if you crash the entire attention, this guy was sleeping and now he's awake. You see, that's exactly what crashes do to your app. They bring attention to the right place. And that's me. All right. So I see we have skepticals everywhere, and even in this room, and there are a number of them. Okay, you want logging. Let's evaluate logging as against exceptions. And then there are a number of topics that I'm going to talk about loggings here. So my issues with logging are as listed. The first one of them, they are indistinct. I mean, we have a haystack of logs. And go ahead, tell me, can anyone tell me which log I'm looking for in here? Which one is important to me? At least a little bit. Sorry, your time is over. Let me help you. So I'm looking for the memory log. I was looking to see how much memory I allocated and how much I freed during the last GC. That was what I was looking for. So there is a haystack of log, and you have to do a good job of finding the right one. And instead, exceptions are in your face. You will see them from miles away. Even my wife sees it from the kitchen. And you don't have to really focus on them because they are out there. They're red, they're bold, they're formatted in a different way. They talk to you. How could you give the argument to login in this case? All right, next one, hard to choose. What I mean by that, so I'm going to take this example from Android, but the whole conversation is not just about Android. It's literally about everything. So in Android, Logcat has different type of logging. So we have V, we have D, I. We're not done. Warning, we have one more. Error. You think we are done. No way. I have another one, assert. Are we done now? For this talk, yes, but in real life, no, we have another one, so I didn't include it. You see, there is a number of them. If we are a normal developer, we are tired enough. We don't want to choose these ones. We don't want to go look at that another Confluence page and find the right type for our logging. We just pick the debug. I honestly picked just the debug. And if you're a 10x developer, you'll go with the error. The others are just useless. And have fun finding that. Exceptions, on the other hand, when you throw them, everyone knows what you're talking about. And you don't have to zone out. You don't have to go look for another Confluence page and read hundreds of lines of documentation to find out which one you have to use. It's part of the code. If the variable is null, just throw null pointer exception. Okay, HTTP throws IO exception. Illegal state exception if your object is in the wrong place. And the other ones that are come out of you. And again, the system ones are also here. Don't forget about them. So exceptions are much easier to choose at the time of writing the code as opposed to the logging. And the next one, I love this one. With login, you have to manually go to every room and gather the information you need for that piece of log. I mean, that's daunting. Let's look at a simple example here. So we have log.d, again, back to our beloved Android ecosystem. And log.d requires a number of parameters, arguments, whatever you like to call them. The first one is tag. In the first few years of my career, I used to just use main activity class name as a tag for my logs. And I used to use that class name as static variable, and I used to pass it to all the other activities as well. So everywhere you would see main activity as a tag. And in fact, there is a whole library built to remove that tag for you. It's called Timber. Thanks, Jake. There is another one, message. I really wish you guys don't have that colleague that is crazy enough to leave a lot of cursors in their logs. It's not fun to debug that, especially when families are involved. But I have had. And it was like an embarrassment moment, trust me. So yeah, messages. You have to provide the messages, and I hope your colleagues are sane enough, not like mine. The last one is throwable. Who wants a throwable in a log, right? After all, we're logging, not throwing. I mean, let's ignore that guy. And then again, have fun finding that log in the haystack of logs after you've logged it. Too many logs in one sentence. All right, now let's see how does exceptions look like on the other hand. So exceptions, all you need to do, and I mean all you need to do is to just create them. Sorry. Have fun looking at that slide while I'm drinking this water. Did you enjoy it enough? No? Should I take another sip? All right. So no tags needed. I mean, when you throw exceptions, the type is already a good of a tag. So you don't have to provide another tag. If you don't want to provide a message, fine. Stack trace gives you all the info you need to find the log, to find the place that is crashing, to find what is the reason, just by looking at this stack trace. And the last but not least, again, if you don't want to provide a message, fine. The name is already talking to the developer debugging. So, I mean, it's a clear win. Next one, addressing. After all, we are doing both of them to address the issue in our app, right? Right? Okay, hopefully. So, addressing logs are a whole different story. If you want to find the right bug, you have to check them regularly. And by regularly, I mean every day. How many people actually check their logs? Let's see a round of hands every day. Wow, you're brave. Well done. Honestly, I didn't expect. Oh, 2. Nice, nice. 3. Thank you so much. You already proven my point. Anyway, so. So yeah, it's hard. You have to go and check them every day. They're not delivered. You have to go to them. The next one is finding the right one. Again, I showed you a haystack of logs, and you had to find and pick the right one, and then also set the severity level. How do you know this log is important? How do you know that you have to wake up the developers from their morning sleep and bring them to work on these important logs? You don't know that unless you have another Confluence page indicating everything. And the next one is assigning to the right team. So not that you just have to find the log, now you have to find the team as well, because logs, in their essence, they don't have any meaning of their root origination. So you have to find the place that is originating from and then assign it to the right team. We're not done yet. Velocity alert. Unless you're building the server yourself, you have to set the velocity alert yourself. But what I mean by that is that how many of that type of log you need to see before calling those developers? Poor them. On the other hand, handling or addressing exceptions is fast, smooth, and a sweep. Let's see that. So they are highly prioritized, as I've shown you. Literally everyone, even the guy wake up from sleep, wanted to see what's happening. So they're prioritized. And they're usually delivered to your inbox. You don't have to go find them. They're coming to you. You don't have to look for them. They're everywhere. They can be assigned automatically. So because they have the meaning of where they're happening, which part of the code they're originating from, they can be assigned automatically to the right team that is responsible for that module, code base, or code path. The next one is if you don't want to set the severity, it's fine. Just set it based on a type. So if you see a null pointer exception, maybe you can skip that for another month or two. But if you see SSL pinning exception, I mean, come on. No one is going to use your app if their SSL is failing. So severities all can easily be set based on a type. The next one is alert. So if you're using the de facto solution for reaching the exception, Crashlytics, you don't have to worry about it because Crashlytics already do that for you out of the box. And if an exception is keeping happening in a recent time, then it will just pop out to your email, hey, buddy, you want to check this guy. He's popping our door a lot. And I think this is the last time, hopefully. So on logs, you have to build the entire thing by yourself. So you have to build the server, you have to build the support around it, and everything I just mentioned. Yes, we do have Firebase event, but to use it properly, to use the values that are coming from the Firebase event, you have to pay for it. It's not for free. On the other hand, exceptions, services that are out there already are mostly free. Crashlytics is free, Sentry is free, Yandex is free, Bugsnag half free, but they do the job, and almost everything that I've mentioned is done already out of the box with them. So you don't have to care about it. Your company doesn't have to invest into building a service for them. All right, so back to our question. Logs, they're not bad. What I've been saying is that they're not bad. They have their own place. They are good and useful, but they're not a replacement for exceptions. That's what I've been trying to say. Exceptions, they still have their own place. With that said, I'm going to go back to my beginning question. So exceptions, are they bad or good? This time, all right, this time I have another answer. So they're definitely not that bad. I mean, they help us a lot. Give them that. But good, it depends. If you go crazy and keep throwing exceptions everywhere, then it's going to be exception-driven programming. And we already know that it's bad. So avoid it. But if you use it at the right time, right place, like the ones that I've shown you, then you're definitely going to benefit from that instead of losing time and money. So just think about it next time when you're coding for your company and use it wisely. It's going to be beneficial rather other way around. So with that said, I'm going to say happy crashing, everyone. I hope you all enjoy the conference. I hope you don't crash your apps. You don't have to, actually. And if you have a crash happening in your app, definitely reach out to me on Twitter. I can hear and sympathy with you, but I might not be able to actually help and solve your problem. That's down to you, but I'll be happy to say hello. And if you're interested to join me and my ideas, definitely check out our careers page on revolut.com/careers. That's it. Have fun. I guess we have time for questions, but if you dare to ask, I'm going to crash. I said it already. I'm safe.